architectural depth is related to the way how your organization works, how you define product, how you release, what's your strategy.
You might also be a little bit worried about budgets, about tokens, how they're being used.
Typical industry answer is if you have a problem with AI, use more AI.
What type of patterns do you expect there?
But if you have needless creativity, you create lots of problems and frictions in your organization.
The quality that you find in industry of the code is not great. If you look at what LLMs generate, also not great.
Another observation I see is that everybody feels they're way behind everyone else.
Hi, welcome to the Signal Podcast. This is our monthly podcast where we turn IT complexity into business clarity. Recently, we released the State of Software 2026, and one of the interesting stats in there is that half or slightly over half of all code that we analyze, that we see in the market, has an architecture quality below what is recommended. So the architecture is not great. We know that wherever AI is introduced, it amplifies problems like these. So today, to talk about what this really means in practice, I have Željko Obrenović from the Aviv Group, who is the chief architect. Welcome, Željko.
Thank you.
Good that you're here. To begin with, let's talk about what architecture really is. So we know software architecture, and there's enterprise architecture. Can you define architecture for me?
There are different views on it. Of course, there's no one single definition. There's even articles written to collect all the definitions here. I like particular definitions that look at the outcomes of what architecture aims to achieve. And maybe the one I'll select for this one is that the role of architecture is to limit needless creativity of people that are building and maintaining systems. I think it's very relevant for AI here, because if you have good architecture, you want creativity. You want people to be creative, but you don't want them to be needlessly creative. You don't want everyone to use different programming language, everybody use different patterns, everybody to use any naming there. You want to have minimal creativity needed for business goals, but no needless creativity that complicates how your organization works. And I think this is maybe the best definition I would like to use here. And it also then amplifies what are the consequences of that. Because if you have needless creativity, you create lots of problems and frictions in your organization, because people cannot transfer knowledge, you cannot collaborate effectively, you cannot scale what you're building. And with AI, you end up exactly in the same problem, because the biggest power of AI is unlimited creativity, and a huge part of it is needless for what you want to do. So if you don't have mechanisms to channel this creativity to solve your business problems, you end up with huge investments in needless creations, which are then not necessarily cost effective, and probably return investment may be negative after some point.
So your needless creativity definition works on a software level, because you on sort of the most basic level of architecture, and it also works on an organizational level, so that you want to bound it.
And another maybe aspect of architecture is that it is impact and connects to organization, product, business, and strategy there, because lots of technical depth is very technical, like version of library update, making sure that you're up to date with the frameworks. It's not something you discuss with product peers or with business strategy. You just need to do it and make sure it runs. The way how you define modules, the way how you define dependencies, the way how you define domains has much bigger impact on how people work, how they collaborate, how quickly you can bring something to market, how strategy is being supported there. And I think that's another dimension, that good architecture is invisible in organization, meaning that everything works smoothly. You don't even notice that it's there. Bad architecture introduces friction. So when there is a problem with architecture, then you have lots of frictions. You have lots of unneeded dependencies. Any minor feature may require 20 teams to coordinate. You can accidentally change one part of the system, introducing bugs in the other. It slows you down. It creates lots of bad energy in the whole organization.
So good architecture makes it look easy.
You don't notice. Good architecture, you don't notice. Not sure if it's a good moment to mention, but I had a friend of mine, is a guitar player, and he actually was forming a band and decided, actually, he was the best good guitar player, decided actually to be a bass guitar player rather than the guitar player, because bass guitar is
all guitarists think they can play bass.
Yeah,
yes,
but the bass guitar is critical for working of the orchestra, because it connects the drum section with the melodic section one.
Yeah.
And he said the very important quote: if you have a good bass guitarist, what you hear is the whole band sounds better. You don't hear bass guitar.
No.
if you had a bad bus, then you see like disconnected instruments happening there. I think that's kind of what architecture, in my view, is.
The bass guitar.
The bass guitar here. So the sound of architecture is that the whole organization sounds better. It's moving faster, smoother. If you start to see diagrams, dashboards, but there's lots of friction.
Those are symptoms that's not quite working yet.
Then you suddenly see a kind of separate instrument competing and not aligning in one direction.
So as chief architect, you're responsible for this. Is that how do you inventorize this? How do you actually know how much architectural debt that you have?
You need to. I would say start with the basics. I think at the end of the day, it is all software. It will going to be released somewhere. It's going to run somewhere. Someone's going to write it. So I think having good grip. I have basically two mantras to follow to get the transparency. So one is show me the code. Talk is cheap because I work with the organization with about 100 teams. We have 10,000 repositories, 800 AWS accounts. So I cannot just talk to every team and let them draw the architecture. So I really do rigorously periodic source code scans to really understand what technology is being used, what trends are there, who is working with, how people are connected. And the other is follow the money. And particularly in our case, we use AWS, we use cloud. So we have very good transparency where and what are driving our costs. And of course, now more recently also AI and tokens is another dimension. So basically following the money and looking at the source code is the way how I get the big picture, and then from there you can zoom in and go more sharp on other topics.
So notoriously, technical debt is something you shouldn't all solve. Any software system, and you've been in IT for quite some time, so any software system you find has problems. There's not a perfect system out there. But the majority of these problems you should leave exactly where they are because it's just not interesting to actually address them because you don't get a payback. How do you do this for architectural debt? Is there a similar system or a similar principle behind it that you also don't have to repay all of this? And how do you choose what do you repay?
Because architectural debt is related to the way how your organization works, how you define product, how you release, what's your strategy, you really need to be very close to strategy, to the product leaders, to managers, to understand how this is going to evolve. Because the technical debt, there are lots of aspects of technical debt you can just solve technically.
Yeah.
To really prioritize properly what you want to do architecture, you really need to understand where organization is going. So strategy, like in our case, for instance, very big example is we 4 years ago embarked on the journey to go from siloed country-specific systems to build one pan-European platform that requires huge organizational change. So going from local teams to have central teams, architectural changes, we have built multi-tenant usable components. And now such is changing. Now we build part of central platform, now we're going more local, and now teams are going from central setting to the one. So you need to anticipate as soon as possible these kind of shifts, because if you're reactive, you're going to invest like 3-4 years in building something that hardcodes a particular way of working, and then you're surprised by changing strategy, and then it's very complicated to do it. So I think that's the one main, you need to understand where your organization is going, anticipate 6, 12, 18 months, even more where it's going to go. Work very closely with product leaders, like what's the value you want to get, what aspects you want to accelerate so you create more independence. And then you can then prioritize things, because as you said, if something has, it's like red on the SIG report, like scores low, but we're not going to invest there. There's no expectation that the traffic will grow. Then we can just leave it there. On the other hand, if there's some high quality part, you could say maybe leave it there, but if you want to accelerate there, maybe you actually want to invest extra there just to make sure that it could be more independent and so forth. I think this is very important to have this network and conversations outside of technology, and then use tech as an input rather than the main decision driver.
So let's bring some AI into the discussion. It's
Definitely.
a hard topic to avoid here. So do you... So one of the findings about AI is that it notoriously it has an interesting relation with architecture, in that it typically tends to re-architect and come up with new solutions. How do you deal with this when you have large existing platforms that you want to do things in?
I mean, maybe two dimensions here. So one is, I think, legitimate question: does architecture anymore matter with strong AI tools?
Sure.
Because, as I said, many of the concepts of architecture are actually organizational people concepts, like coupling. Computers don't care how strongly are coupled the units or how many parameters you procedure, but people do care, because they care how they're connected to others, can they work independently or not. And now if you're building systems where you actually AI is doing it, not people, do you really care about these people-centric metrics.
Yeah.
It doesn't really matter how it's coupled because the machine doesn't care. And I think the problem, of course, is there is a set of systems where it really doesn't matter. So I think what we're seeing now is also a range of smaller apps where frequently like low code would step in. You can actually now build some things. One person, small team, they can build something useful for organization, which is small, couple of days work. Architecture metrics inside, if it's not perfect, doesn't really matter because you can rebuild it. If you keep it small and it brings value, you can get away of it. And I think that's a lot what we see also on a part. The problem, of course, where I think it breaks is two-dimensional. So one is legacy.
How is this still a problem right now? What is legacy for you?
Yeah. My favorite definition of legacy is that it runs in production and makes money. And I think that's the main...
But we want this.
That's exactly the main problem. So legacy has a typical negative connotation, but there's actually tension that you have with something that's difficult about this legacy. So difficult to maintain, difficult to change, and value it has. Because if it just be a bad code or bad system, that's easy. You just throw it away. The problem with legacy, it actually has huge value. And that's exactly a challenge, how to keep this value while you are making it easy to maintain, easy to change. I think this is a bit also the tension currently because industry is using lots of these simple examples to illustrate this is how you can go quickly. Standard industry answer is if you have a problem with AI, just use more AI. But if you really look at bigger context, more complexity, what you really know is that you end up with amplifying lots of bad patterns, lots of bad architectural decisions, lots of dysfunctions in your organization at the same time as you're growing also good ones. I think that's...
a counter argument could be, couldn't we essentially maybe a year from now be much more explicit about the type of patterns that we want to see in solutions when agents start building things? Is there an inherent problem? Is the question behind the question? Or is this just where we are now?
I mean, this is a valid question because things are moving so fast. The context window is increasing exponentially. At some point, AI will be able to do. And I think that the enemy boils to two things, and I think architecture plays a role in this. One is kind of trust, and the second is sustainability. So one is, can you trust the solutions that are being built so that you are confident you're going to put in production, solve your problem, and you're not going to create some damage? And because of the speed and size of the systems being built, it's very difficult to build this trust. So the classical mechanisms that you use to build trust, reviewing code, having peer sessions, architecture reviews, not only slow things down, it's just not manageable. So I recently talked to one CTO in Amsterdam scale-up startup. He said, I just approved a pull request with 19,000 lines of code churn. It's like 1 or 2 many years of effort in one pull request. It's kind of... It's becoming more and more normal. So there is no way that any human, any architect, any architecture board will ever be able to review this.
Did they approve in this example?
Yes, they do. Yeah. They do. So they invest. So that's one aspect. So currently, the only way to build trust is brute force. Yeah. Because you have so much change here. So what they're doing, they're investing incredible lot in testing. So they have incredible suite of unit tests. But the biggest problem became that. They're burning laptops, the unit tests. Every change requires so much unit tests, so they need to get solutions to outsource. I think that's one issue. So if you don't have a good architecture, some way to control splits, understand what's going on, then you'll always be approaching trust in brute force way. So you basically, if you want changes to make it bigger, so you need to test it more, you need more power, then you make bigger changes and so forth. And then it becomes also unsustainable. It's unsustainable also financially because, you, of course, good thing about brute force is it's a very simple management mechanism. If you get any positive return on this investment, you just invest more and you get more. At some point, of course, you have diminishing returns, and then it can not anymore give you back the investment you have. And it's very fragile. You always depend on the latest and newest version of the model. Yeah. At some point, if that model is not available, you're really stuck. And we've seen this example limited with the kind of the latest part, of course, with a couple of days. But if you spend a couple of months investing a lot to maintain system with brute force, with latest model, and this model is not available, you really cannot do any other changes with lower model there. And exactly the problem with brute force is you use exactly the same brute force as anyone else. And if someone else has more money, then they can outforce you purely there. But if you are clever, if you could actually make progress by making much smaller localized changes that fit in a whole, then you can, with much less investment, actually compete with people that have much more resources, but are not as well organized or are not mindful about that.
So a very central theme in what you explained about what you can do to make your organization a bit more ready to take the benefits of what LLMs actually offer, what the AI offers, is that you have a lot of information centrally available. You talked about friction. To be able to understand what that friction is, you need to not do that anecdotally, we discussed, but you need to make sure that you have actual factual information available, that it's continuous, and that you use it as a basis. I don't think that's very common yet. I don't see many organizations have that available on their software, on their IT. Now, when you talk about finance, for example, that's far more normal. Also, if you look at a management team, if you look at the board level, then everybody has a basic knowledge about finance. Some people more than others, but everybody knows the basics and understands the implications of the basics. Whereas for software and IT in general, that's not at all the case. What I often feel is that this idea that software is really complex and really hard, and that's something, we need training, whereas I think finance is much, much harder. It's much more complex than software actually is and the basic concepts behind it. How do you recognize this? Is it something that's the case in your organization?
So first, maybe I recognize that finance is much more complex because I work in a pan-European company. So being able to do declaration of taxes, intellectual right properties is extremely complicated financial topic there. And I completely understand that people underestimate. It's not just return and investment there. But I do also recognize that I would say on board level, there is little in-depth understanding of computing trends and the way how software engineering works. It is frequently delegated to sometimes even externally to consultancies, or is kind of treated as a black box with kind of very few parameters. And I think this is probably the change that will need to happen in future, because in my experience, companies that are most effective using AI are one that have at the C, director, VP level, very in-depth people that very in-depth understand how things work. They really invest also systematically, not just a few hours a month, but really systematically every week, enough time to learn how things work. Because if you have the C-level understanding of your business where you go, and you also have in-depth understanding of how things are going, you have two benefits. First, you can really, with minor decision, because AI is amplifier and strategic context, so you can amplify AI on the very strategic topic. You can really have huge leverage. And second, I think what is important is you prevent panic or this FOMO, fear of being missed out, because another observation I see is that everybody feels they're way behind everyone else. And then you actually talk to your peers and then you see, look, we're already working
We're all behind.
That's not that bad. So I think investing systematically in education and the C director plus level will help you to leverage investment properly and also to avoid panic, so that you're not doing things because you're in fear of being missed out, but also because you have good understanding and you can be strategic about it. And strategic meaning where you want to use AI, because current decision, we just want to use AI everywhere, and where you don't want to be, very explicit where you don't want to be.
So I briefly want to also talk about tokenomics. I think at the scale at which things are happening in your organization, you might also be a little bit worried about budgets, about tokens, how they're being used. Are you making an effort to have your organization become a bit smarter about how and when they use AI?
Of course, everybody's making effort to become smarter how to use and when to use AI. I cannot say that we have cracked the issue. Of course, we are still, depending on the organization, work in different ways. Sometimes you can be exact and define particular budget and kind of stay in it. Sometimes you just open it up for people to learn. I would say there are a couple of issues here. So one is balancing the need to learn and to control budget. I think that's the tension we feel a lot, because on one hand, financially, of course, it's very easy to increase the cost without generating any value. So you want to keep this under control. But on the other hand, we haven't used AI enough to understand exactly how it works and how it could work in our system. So then the one issue is that if you too quickly optimize for return on investment,
you lose up on the experiments that you can.
You actually don't learn enough, and then you end up in the same problem. If you don't learn enough, then you can amplify the wrong things, which in the end you stay in the budget, but then on long run you are making lots of bad decisions, which will have bigger bigger consequences. And then I think maybe one thing about tokenomics or in general, I see also opportunity here. Of course, there is a huge risk here because typical industry answer is if you have a problem with AI, use more AI.
Yeah.
And I think that's why we see lots of these brute force things. So you have, of course, build something that you can understand, then how you going to understand it or how to trust it, then build more tests with AI that becomes bigger, then use more AI and more AI. So it's burning tokens. On the other hand, I think tokens will create level of transparency that will enable us actually finally to fine-tune our understanding where are the bottlenecks in our architecture. I think that's also a shift that happened with public cloud. So before you have a black box in a data center, now I know exactly which resource is being used by whom, when, and which pattern. And that enables you some really precise micro-optimizations and splitting. And I do expect, we are still not yet there. On the negative side, of course, more token spend. On the positive side, much more transparency on what's going on and why in your architecture.
And what type of patterns do you expect there? So if you paint a picture of the near future, what would you look at in token use?
So one symptom I see as a problem is what I call continuous re-architecturing. So one reason why you have architecture is you have some decisions that are difficult to make and difficult to change. So you spend lots of time define which technology to use, for database, data models, APIs. Now with AI, the problem is this: what's difficult to change is actually threshold is lower. Now it's not difficult anymore to change data model. You can even change the database on the fly. But what you end up is you continuously re-architecturing everything. So minor change in one feature, say, well, actually, maybe it's good to change data models. You change the database, you change the API, you change all dependencies, and it works. But it burns down the tokens. So everything is burning there. So the whole infrastructure to run is costing a lot. The refactoring is costing a lot. Also, people are burning because suddenly you're not reviewing any more free files. You're renewing, as I said, 120 files with 19,000 lines of code. So what you could, I would say, symptom of good architecture would be if you could introduce changes that are not end-to-end burning everything. So if you could have an increasing high number of changes that are localized. So basically you look at the particular change, there's file, clean modules, you have everything to understand the interfaces, then you can make a very quick change, test it, and it's done. If you continuously change everything, then you will don't have stable architecture. And that's architecture that you cannot really maintain long-term, you cannot control. And token users can really show this pattern very clearly. You can really see, is your change really being as you want to be? So you have some stable core and then you're expanding localizedly, or is your change always end-to-end? If it's always end-to-end, that's not sustainable. You don't have stability. You don't have way to control and compete to anyone who has more resources. If you can do localized changes, then you have some leverage, which you can do. And I think this token can really show level of transparency, bring level of transparency to understand where you have a problem and also how to solve it.
I get what you're saying, but many of the things seem to be it seem to be built upon the idea that you know a lot, right? So you need or that the code is actually that the existing systems that you work at are somehow well built. I think we find again, and I think it's a finding we repeated over the years, and maybe you also recognize, is that the quality that you find in industry of the code is not great. If you look at what LLMs generate, also not great. I think for security, it's twice the amount of vulnerabilities that comes out. So how do you deal with that? Is that something? How do you make sure that you get to the situation that you described, that you don't have to generate end-to-end, that all the prerequisites are in place to actually do this more localized optimization?
I mean, that's exactly the winning formula that business needs to find. That's when you have the architecture, then when you have the technology, when you can compete. Because if you don't find it, then you're brute forcing, and then you're basically competing with everyone, as I said, who has the same or more resources with the same technology. Yeah. If you can find what is the model that works for you in your domain, that is the advantage that you're going to leverage. And that's why AI actually works much better in organizations that already work good. And it's just basically stuck in organizations that don't have that one. So I think, in essence, it is in many ways going back to the basics. I would say here. So, as I said, many architectural decisions, the way I organize architecture, aim to reflect how you want to run business. So where you want to compete, what kind of users you want to serve, what value you want to generate. So going back to the basics, understanding that and making sure that it's very explicitly present in architecture is one. And then also understand, then increasing the autonomy and parallelizing. So being able to say, okay, now when I business-wise understand how it works. And I will also need to understand whether business-wise it makes sense for me to have more autonomy, to experiment more, and so forth. And when you have this understanding, then you actually can propagate this to architecture and then create systems where that became stable. So you don't want to have AI to redefine how you approach the market, to redefine, of course, you can use AI to help you there. But then if you have this stability where you want to experiment, where you want to accelerate, where you want to be stable, where you want to go parallel, then you can actually build a system where you could then have a much isolated problem. So you can actually use AI brute force, but on a much smaller scale.
Bounded
there. Yeah. And you know, of course, if there's something wrong, it will impact particular line, but not everything there. So I think in ways, it's kind of really going back to the basic what architecture aims to be. So it is connecting business to technology, but I think here it really needs to be much more explicit.
Clear. So Željko, thanks. This has been a very interesting conversation.
Thanks for having me.
I recently read 2 interesting studies by Gartner. By 2027, architectural debt will account for 80% of all technical debt. And the other one is that AI, by 2028, a year later, AI will create more technical debt on architecture levels than it solves. I think many of the sort of tips and concepts that we talked about in the past conversation, I think these will help. I think I hope that these will actually prevent organizations from getting into these situations. So thanks a lot. See you next month.